Okay, so I just want to make a couple of brief notes about epochs, equalizers, and kernel pairs. So here's a very sort of fast illustration of a kernel pair. So suppose we have this so we're talking about the category of sets for the time being because it's simpler. So suppose we have this function f from a to b. We want to find out the kernel pair of f. Well, we can quickly graphically illustrate it by just drawing a kind of undirected graph where we'll link any pair of elements in this set capital A when they're sent to the same thing under f. Okay, and then this, we can think of this sort of set of undirected edges as a kind of subset of A times A, and that's basically what we can think of the kernel pair as. Now, but also we can think of the kernel pair as this pair of arrows h comma k. So if we extract this kind of sub-object of A times A, this R here with h comma k being this kind of kernel pair, which is really sort of describing a sub-object of A times A. Well, we can do P1 after that to get H and P2 after that to get K. And then we basically have these two arrows H and K from R to A. And so that's the way of thinking of the kernel pair as an actual pair of arrows. So one of our results for topos is that every epoch is the co-equalizer of its kernel pair. So here's an example of this. Here we have this epimorphism F, and if we work out its kernel pair, here it is, and we draw it out as these sort of parallel arrows, then we work out the co-equalizer of this, then we'd be joining 1 and 2 because there's stuff like 1, 2 here that makes both of them. And then you see that this basically looks just like B, and this this co-equalizer of H and K, sorry, it looks just like F, yeah, basically. So this is the idea, that we can actually consider this, because this F is epoch, we can consider it to be the co-equalizer of its kernel pair. So what's the intuition behind this? Well, some rough intuition is like this. We'd be identifying I and J when we're constructing the co-equalizer. This is in the category of sets, but the way this works in topos is kind of similar. But we'd be identifying I and J when, so these would be I and J in here, for example, this 1 and 2, when there exists a V in R such that H of V equals I and K of V equals J. So for example, this 1, 2 here goes to a 1 and a 2 under the red and the blue, sorry, the red and the green, and therefore 1 and 2 get identified. Okay, now this happens, just another way to say this is if and only if there exists a V such that I comma J equals H comma K after V. And this happens if and only if I comma J is in H comma K, and then by definition of kernel pair, this happens if and only if F after I equals F after J. Now this is fine when F is epoch, because then everything is sort of being pointed out in this target set by something being sent to under F. Something has been sent under F to that particular place for any particular place in here. But if F is not epoch, then there'll be stuff in B that's not pointed out, stuff that nothing's mapped to in A by F, and therefore, it wouldn't appear in this kind of co-equalizer of H and K, but it would appear in the kind of target set of F. So we'd have disparity there. So that's kind of why I think we need F to be epoch. Anyway, that's one thing I wanted to say. The other thing is just briefly about quotients. Okay, so the quotient of a relation R equals HK is a co-equalizer of H and K that has H and K as its kernel pair. Okay, so this is for an equivalence relation R equals H comma K. So how do we construct a quotient? Well, we can do it. We have quotients in toposes, and here's the basic idea. We form this kind of arrow, which is basically going to send a Y in B to the quasi-set of W in B that's in this equivalence relation with Y. Okay, so you can think of this basically as sending something to the kind of set, I mean in the category of sets, it's sending something to the set of stuff that's equivalent to it. Now if we do an epimonofactorization of this, we're going to have that this monomorphism here, this I, is basically going to be the collection of equivalence classes, and then this Q here is going to be the quotient of R. And yeah, that's it.